In this video, we're going to be looking at the function generator power. And we're going to use two methods to determine if there's power being used by the function generator. One of them is with this kilowatt meter, which is currently showing us 55 watts of power. We have the function generator plugged into its outlet. Function generator is currently running, but the output is disabled. So just to prove that this is indeed the function generator power, I'm just going to turn the function generator off for a moment. Okay, function generator is now off. And you see our power has gone to 0. Turn the function generator back on. And we're back up to 55 watts roughly. Fluctuates between 54 and 55 watts. So that's with, again, the output disabled. So when that disable button is red, that means there's no output whatsoever. And you can kind of verify that by looking at the scope too. The second method we're going to use to verify function generator power is by, if we go to the schematic here, remember there's a 1 ohm CSR installed here. So we're going to be measuring the voltage across the function generator and the voltage across this 1 ohm CSR, and computing it essentially the same way that we were computing the battery power. Having the scope multiply those two traces together and get an average reading of the function generator power. So here's our probe configuration. We have our function generator voltage right across these two terminals here, and we have the function generator 1 ohm CSR right here and its associated probe. So let me first off just re-enable the generator output. You notice there's nothing showing on the scope trace at the moment, so let's just enable that. Again, I'm using plus and minus 10 volt gate drive from the generator. And what we have in the display, the bottom purple trace, is the function generator voltage. And we're on a scale of 5 volts per division. So not sure what we're seeing here. It's roughly about plus or minus 5 volts, I guess. And up here we can actually see a current on the current trace already. Looks like both a positive and a negative current. And I'm using a 10% duty cycle from the generator. So let's get a close-up of the values. So it looks to me like we've got about just a little under half a watt of average power going into the circuit. We don't even have the circuit powered up yet. Now, something that I also wanted to show you was the change when the function generator is enabled and when it's disabled. So notice it's about 59 watts currently with the output enabled. I'm going to disable the output. So our display is pretty well flatlined now, and our power consumption by the function generator has gone down about 4 watts. I'll re-enable it here. And you see the power consumption from the grid go up about 4 watts. See, it's fluctuating between 58 and 59, so it's using somewhere between 3 and 4 watts when the function generator is enabled and driving the circuit. What we see going into the actual circuit is only about half a watt, though, a little less than half a watt, as you can see. Now the reason for that is because you have to remember that the function generator output has a 50 ohm series resistor. So the bulk of that 3 or 4 watts is being dissipated in that output section, the generator itself, that 50 ohm resistor. So that leaves about half a watt going into the circuit from the function generator. Now again, this is with no power hooked up at all. So you see the battery connection here is open, it's not been made. So even with no battery connected, we're still using about half a watt of power. Now you may be asking, how is that possible? Well, if we look at the circuit here, let me just pull out here so we can get this whole section in view. Here's where the function generator is situated. Its reference, it's a positive output or a red lead. So let's say, for example, let's start with the red lead being high and the reference being low. So we go up here, if it's plus 10 volts or so, it's going to turn on Q1 because the voltage across the gate to source of Q1 is going to be, 5, 10 volts, whatever the voltage is. We can measure it. But at the same time, you'll notice that the function generator output can pass through this body diode of Q2. And so there's about a 0.7 drop across that diode, and it comes over here to the drain of Q1. So the function generator kind of does two things. It turns on the MOSFET and it supplies its own power, so to speak, to the drain of that MOSFET. So it's kind of acting as its own driven switch. So that essentially just turns on and connects the function generator output over to here, which then circulates back through the function generator. So the current path is more or less like this. And conversely, when the function generator output is low, Q1 is off, Q2 turns on, because now the source is low with respect to the gate voltage. And the same thing happens. The function generator current goes through the Q1 diode and the current circulates in this direction. So in both directions, no matter the polarity of the function generator, we have current flow when there's no connection, battery connection to TP3. So now let's connect the battery and see what happens to our waveforms. Now you can see they get pretty noisy. Of course, our CSR setting is a little more sensitive. It's on a 200 millivolt scale, so there's a lot more noise pickup now, as you can see in this trace. But let's zoom back into our measurements. Well, the output or the power of the function generator has dropped a little bit, so it's about 0.44 watts now instead of about 0.48. But you can see that it's still providing a little under half a watt of power to the circuit. Okay, that's it for now. Okay, actually, while we're at this, let's do an experiment with the function generator and essentially disable both the positive and negative excursions and see what happens to the waveform and the power. So presently you can see I've got plus 5 volts, which equates to about plus 10 volts actual output, and negative 10 volts. So let's start with the plus, and what I can do is I can decrement it in 1 volt or 2 volt steps with this vernier here. So I can take it all the way down to 0, back up to plus 10. So I'm going to do that now, show you the result. So I'm decreasing it now, and we are actually at 0 volts now, positive output, and we're still negative 10 volts negative output. And you'll see that the mean function generator power hasn't decreased a lot. It's about 0.4 watts now as compared to 0.44 watts before. So I'm going to take it back up again. Okay, we're back to plus 10 out and back to about 0.43, 0.44 watts. I'm going to switch to the negative side and decrease it. Let's see what happens to our function generator power. And we're at 0 volts now, so the only thing we've got is, as you can see on the display, from 0 to plus 8 or 10 volts peak from the function generator. But our mean power has gone down considerably. Like, it's only about 10% now compared to what it was before. So it would seem that I'm going to increase it back again. It would seem that the negative portion of the function generator, the off portion of the cycle, if you will, is responsible for the majority, the bulk of the power being supplied. Okay, that's it for now. Does everyone know why the function generator negative portion of the waveform is responsible for the bulk of the power from the function generator? Let me just demonstrate one more time. I'll be decreasing the negative portion of the generator. Okay, we're now at that's 0 volts. So we still have a positive excursion. A little bit of a triggering issue here. Let's see if I can fix that. Okay. So again, we're about 0.048 or 0.049 watts when we've completely disabled the negative portion of the function generator output. So Q2 is never on. And let's just start to increase it here again. Well, if you haven't guessed, or you don't know by now, it's simply because we're only using a 10% duty cycle from the function generator. So the positive excursion is only 10% of the entire period. The bottom excursion is 90% of the period. So logically, the negative portion of the function generator output is going to be responsible for the bulk of the power from the function generator. Okay.